Hello class, today we're going to go over 8.6, which is solving rational equations. We're going to start with a basic one first. We're going to solve 7 over x minus 2 equals 11 over 2x minus 10. Since we have two ratios equal to each other, we can cross multiply to create an equation to solve. So what I mean by this is we're going to do 7 times 2x minus 10. Then I'm going to make it equal to 11 times x minus 2. Now I can solve this equation. I'm going to start by distributing. This gives me 14x minus 70 equals 11x minus 22. I'm going to go ahead and move the 11x by subtracting. This gives me 3x minus 70 equals negative 22. Now I'm going to add that 70 to either side. So I get 3x equals 48. And then I can divide by 3. So I get x is equal to 16. Okay, so when you have two fractions equal to each other like that, just cross multiply and solve. Now the next problem is a little more difficult. We have a word problem. In this word problem, it says the coolant in a car radiator is a mixture of antifreeze and water. The recommended mixture for your car is 50% antifreeze. If you have a mixture of 7 liters of coolant that is 40% antifreeze, how much antifreeze should you add to bring the mixture to the recommended level? So we're trying to figure out how much more antifreeze we need to make this the correct balance, the 50-50 balance, okay? So first I'm going to create an equation in words to figure this out. So I'm going to say, I know the percent water that's currently in this mixture, right? Because it's 40% antifreeze, which means this is for what we want, not for what we have. We want a 50-50 combo, right? So 50-50 combo means 50% water, 50% antifreeze, okay? So we want it to equal 50% water. I'm going to make this into an equation, equals, and we're going to do liters of water in current mix. So that's over here, right? They said 40% antifreeze, so it's 60% water over total liters of the mixture. Okay, so the percent of water, that would make sense, right? The percent of water is the liters of water over the total liters of the mixture. So let's go ahead and fill out what we need to. We're going to substitute to make an equation. So the percent of water we want is 50%, right? So I'm going to make this a fraction, 50 over 100 equals. Now to figure out the number of liters in the current mix, I know that there's 7 liters, but we want to know how much of that is water. So 7 liters times, well, 60% is water. We have to use that as a decimal. So 7 times 0.6 will tell you how many of those liters is water over the total liters of our mixture. Well, we know it's going to be 7 plus however much more antifreeze we add. Okay, so this is our proportion that we need to solve. I am going to cross multiply. So I would do 50 times 7 plus x is equal to 100 times 7 times 0.6. When I distribute, I get 350 plus 50x equals 100 times 7 times 0.6 is 420. I'm going to subtract 350 from each side. This gives me 50x equals 70. And then I'm going to divide by 50. So I get x is 1.4 liters. So we need to add 1.4 liters of antifreeze to make this the correct mixture. All right, let's go ahead and look at example 3. So example 3, we have 15 over x plus 4 over 5 equals 7 over x. So notice there's more than one fraction on each side of the equal sign, which means we cannot cross multiply. Okay, so I have 15 over x plus 4 over 5 equals 7 over x. So one way you can solve this is by finding a least common denominator. So you're going to say to yourself, if you're looking at the bottoms of all of these fractions, what would be a good common denominator? Well, in order to have a common denominator, it would have to have an x, and it would have to have a 5, right? Because all of these fractions either have a 5 or an x in the bottom. So that's our common denominator. Okay, so to solve, I'm going to go ahead and multiply everything by 5x. When I do this, I'm distributing that 5x. So it's 5x times 15 over x plus 5x times 4 over 5 equals 5x times 7 over x. Okay, so when I do this, on the first fraction, the x's cancel out. On the second one, the 5's cancel out. And on the last one, the x's cancel out. So what we end up having is 5 times 15 plus 4 times x equals 5 times 7. And now we can solve. So 5 times 15 is 75 plus 4x equals 35. I'm going to go ahead and subtract that 75 from both sides. This gives me 4x equals negative 40. And then I would divide by 4 to get x equal to negative 10. Number 4 is very similar in this problem. We do want to get a common denominator so we can get rid of those fractions. So looking at these, the bottom of the first fraction is x plus 7. The bottom of that second one could be a 1, and then the other one has an x. Okay, so we need to figure out a common denominator for all of these. Well, I have x plus 7 in the bottom of one of them, so I have to have an x plus 7. The other one just has a 1. We don't have to write the 1 down. The last fraction has an x, so I have to have an x by itself as well. The x that's attached to the 7 does not cover that x that is by itself. Okay, so you have to have x times x plus 7 as your common denominator. Okay, so the reason I find a common denominator is so that I can get rid of all these fractions. So I'm going to multiply everything by x times x plus 7. So remember, I'm going to distribute that to everything. So it'll be x times x plus 7 times 12 over x plus 7 equals 1 times x plus 7 minus x times x plus 7 times 12 over x. Okay, so I distributed the x times x plus 7 to everything. Now I'm going to cancel. X plus 7 cancels out in the first one. Second one, nothing cancels out. And in the last one, the x's cancel out. So I have x times 12 equals, that 1 I can let go. 1 times anything is just whatever you have. So it'll be x times x plus 7 minus 12 times x plus 7. Okay, so now I'm going to solve this. I'm going to work it all out. So I'm going to have 12x equals x squared plus 7x. When I distribute that 12, I want to distribute the minus with it. So it's minus 12x minus 84. So I get 12x equals x squared minus 5x minus 84. I'm going to go ahead and subtract that 12x to make this equal to 0. So I get 0 equals x squared minus 17x minus 84. So when you get to a trinomial like this, you want to either determine if you can factor it or if you need to use quadratic formula. This is in fact factorable. We can do x minus 21 and x plus 4. Once you figure out your factors, you use the zero product property to solve. So x minus 21 equals 0, x plus 4 equals 0. So x equal to 21 and x equal to negative 4. Okay, so those are the two answers I get. Now notice the note here says check for extraneous solutions. So that means check to make sure these answers actually work. So to do that, you could plug them in one at a time. I'm going to go ahead and do that over here. So I'm going to plug in 21 first. 12 over 21 plus 7 equals 1 minus 12 over 21. So this becomes 12 over 28 equals 1 minus 12 over 21. I do notice that I can simplify these fractions. 12 over 28, we can divide top and bottom by 4 to get 3 over 8, or I'm sorry, 3 over 7. Equals 1. The other side, I can divide as well by 3. So I get minus 4 over 7. That 1, you can make a fraction of 7 over 7, so there's common denominators. So 7 over 7 minus 4 over 7 is in fact 3 over 7. So 21 works. You would follow the same process when plugging in negative 4, and you do get the same answer as far as on both sides of your equation, so it does check out. Now example 5 here, we have one more step we do need to follow in order to solve this one. We have the equation 7 over x minus 1 minus 5 equals 6 over x squared minus 1 that we're just going to solve and then check. One thing I do recommend doing is when you're trying to find the common denominator, you want to factor anything that's factorable. So that x squared minus 1, I'm going to go ahead and change to its factored form, which is x plus 1 times x minus 1. So this gives me a better idea of how to find a common denominator. They both have an x minus 1, so I know my common denominator must have an x minus 1. And then this second fraction here also has an x plus 1, so we do have to have that as well. So our common denominator would be x minus 1 times x plus 1. The reason we use this common denominator is so that those fractions will cancel out, right? We want to get rid of those bottoms. Okay, so I'm going to multiply this entire equation by x plus 1 times x minus 1. So again, you're going to distribute it to everything. And that includes the 5, so it'd be 5 times x plus 1 times x minus 1. And then on the other side, same process. So then when you do that, you have x minus 1s that cancel out, and then the entire denominator of the last one cancels out as well. So you have left 7 times x plus 1 minus the entire second part, 5 times x plus 1 times x minus 1 equals, and all you have left on that last part is the number 6. I'm going to go ahead and start multiplying these things out. If I distribute the 7, I get 7x plus 7. I'm going to go ahead and FOIL the two binomials first, so this becomes minus 5 times x squared minus 1. Then in the next step, I'll go ahead and distribute that minus 5. So I get 7x plus 7 minus 5x squared plus 5 equals 6. I'm going to go ahead and combine like terms and put this in descending order. So I'm going to put the negative 5x squared first. Then I'm going to put the plus 7x. Last, I'm going to go ahead and do that 7 plus 5. So I get a plus 12 equals 6. We're going to have a trinomial here. I do need to subtract that 6 from both sides to get negative 5x squared plus 7x plus 6 equals 0. Now at this point, I always want to make that x squared a positive term. So I factor out a negative 1 to make it 5x squared minus 7x minus 6 equals 0. And now let's go ahead and factor that. It is factorable. We can do 5x and x, and then 3 and 2, a positive and a negative. So now that it's factored, we can split it up. 5x plus 3 equals 0. X minus 2 equals 0. I'm going to solve each one. So I get x is equal to negative 3/5 and x is equal to 2. Okay, so I found these two answers. We finished the first step of this problem. The next step asks us to check these answers. Okay, so when you check them, you want to plug them in one at a time. I'll go ahead and check over here. So let's see. Let's go ahead and plug in the 2 first. So 7 over 2 minus 1 minus 5 equals 6 over 2 squared minus 1. So I get 7 over 1 minus 5 equals 6 over 4 minus 1. 7 minus 5 equals 6 divided by 2. I'm sorry, 6 divided by 3, right? 4 minus 1 is 3. So I get 2 is equal to 2. So it works there. Now we do need to check -3/5 as well. So that's a little more complicated, right? We have 7 over -3/5 minus 1 minus 5 equals 6 over -3/5 squared minus 1. Okay, so 7 over -3/5 minus 1 is like -3/5 minus 5 over 5, right? Because 5 over 5 is 1. So I get 7 over -8/5 minus 5 equals 6 over -3/5 squared would be 9 over 25. I'm going to put minus 25 over 25. Okay, so now 7 divided by -8/5 is the same as 7 times -5/8. So I get -35 over 8 for that. We still have minus 5 here. On the other side, 6 over 9 minus 20, 9 25ths minus 25 25ths. So we do 9 minus 25. So I get -16 over 25. Remember, we can change this to multiplication and flip that second fraction. So it's 6 times 25 over -16. Okay, so what to do from here? I'm going to change that 5 to have a denominator of 8. So -35 over 8 minus, if I want an 8, I need to multiply by 8 over 8. So it would be 40 over 8 equals 6 times 25 is 150 over -16. So on the left-hand side, if I combine, I get -75 over 8 equals, I can divide top and bottom by 2 on this second fraction to get -75 over 8 as well. So it works in both. All right, since both checked out, we do have both answers. We'll keep them. If one of them didn't check out, you would want to cross it out. That's it for notes today. If you have any questions, make sure you contact your teacher.